So let us write down the inputs and outputs associated with this D-latch. So my inputs are input enable, and D underscore in is one of the input to your D-latch, and your outputs are Q and Q bar. Output comma output reg Q comma Q bar. So these are the inputs and outputs which are associated with our D-latch. Okay. Now, so within an always, let's say it is a negative D-latch, always a great negage of enable. Sorry, let's say it is a active low D-latch, that is always a great not of enable, always a great enable begin if not of enable. If enable is equal to 0, then my latch should work. Okay, it is an active low latch. Okay, if my enable is equal to 0, and if I apply my reset, then my q will be equal to 0, then my q will be equal to 0, and my q bar will be equal to 1. Okay, and followed by end. Else my q is equal to d underscore n, and q bar is equal to not of d underscore n. This is my simple D latch. That's it. So let us write down the test bench for this D latch. So simple, it is an active low D latch. Whenever your enable is equal to 0, then only this latch will be activated, or else your latch will not be activated. That's it. It's a simple code which we have written for our D latch. So let us write down the test bench for our D latch. So how to write down the test bench? Go to sources and create simulation source. Press next, create file, d underscore ff underscore t, sorry, d underscore latch underscore tv is the file name, and press ok, finish, and press ok here, and press yes. So in the simulation sources, in the d underscore latch underscore tv, let us write down the code. Let me open this file. Now here, let me write down my inputs and outputs as reg and wires. Reg, enable, reset, and d underscore in are my inputs of my design, and wire q comma q bar are my outputs. And let me instantiate my design. My design name is d underscore latch. Let me copy the design name and let me paste it over here. Design, and followed by instance name. Instance name is dut, and I'm going to pass enable reset d underscore in q and q bar. So these are the inputs and outputs which are instantiated. Now, next, what should I do is initialize my inputs. Initial begin enable comma reset comma d underscore in is equal to 0, and followed by end. Next is I need to generate my enable signal. How to generate my enable signal? Always at the rate, always hash file enable is equal to not of enable. So I'm generating my enable signal with 10 time units. Okay, 10 nanosecond time period. Now, so within another initial beginning block, I'm going to first of all apply my reset signal, and after 15 nanoseconds, I'm going to apply deset my reset signal. Okay. So first of all, let me show you the enable signal waveform, how it is going to look like, and followed by end module. End module already written. So let me save this. First of all, I will show you how the enable signal waveform is going to look like. Then accordingly, we can decide where to apply our reset signal and input signals, because we are dealing with active low enable latch, right? So first of all, let me make it as a top. So this is my enable signal which I am getting, and this particular latch is an active low latch. That is, whenever your enable is equal to 0, and if you apply your inputs, then only this latch is going to work. Yes. So we should apply our inputs exactly at the negative edges of whenever our enable signal is equal to 0. So we are applying our reset signal whenever your enable is equal to 0. Then only your output is becoming 0, q is equal to 0, and q bar is equal to 0. So we are applying it at around 50, around whenever your 10, that means 15. So after 15 nanosecond, we are making our reset signal is equal to 0. Okay. Next, we need to apply our inputs, the negative at the low whenever our enable signal is equal to 0. That is, after 5 time units, we can apply our inputs. And if we apply, let's say, if our input at 20 nanosecond, then we should make it constant up to the next cycle. That is, up to 30 nanosecond, it should be constant. Okay. So like this, I'm going to plan. So hash 5 d underscore in, hash 5 d underscore in is equal to 1. And for 10 nanosecond, I'm not going to change my input. And after 10 nanosecond, I'm going to change my input to 0. Okay. Let me save this and run it, relaunch it one more time. Yes, so we can see our inputs and outputs. We are applying our input at whenever our enable signal is equal to 0. That's why we are getting Q is equal to 1 and Q bar is equal to 0. Whenever our enable is equal to 0, we are applying D is equal to 0. So our Q is becoming 0 and Q bar is equal to 1. So this is the design for active low latch. Is it clear? Any doubts and queries? Shall we move forward? So let us move with the next design, that is our T latch. So coming to our T latch, again the same. So our inputs are enable, reset, T underscore in, and outputs are reg, Q and Q bar. These are our inputs and outputs of our design. Now within an always enable, whenever there is a change in the enable signal, if enable, we are going to consider a active high enable signal. If I apply reset signal, then my Q begin, then my Q should be equal to 0, then my Q should be equal to 0 and Q bar should be equal to 1. Okay, and followed by end. Now, next, what should I do is, what happened here? Q bar is not declared. It's Q bar. Okay, next, else if my T is equal to 0, if my T underscore in is equal to 0, then my Q should be constant, it should not change, and Q bar should also be constant, it should not change. Okay, so within an begin end block, I should write this down. Else if my T underscore in is equal to 1, then my output should get toggled, that is Q should be not of Q and Q bar should be not of Q bar. So within a begin and block, I should write it down. Yes, so this is our T latch code. So whenever your input is equal to 0, output should be constant, and whenever your input is equal to 1, your output should toggle. So let me save this and let us write down the test bench for this. So create simulation source. Next, create file T underscore latch underscore TB is our test bench file name, and press OK and finish. Yes, so let us write down the logic for our test bench. Open file. So we are going to declare our inputs as reg and outputs as wires, enable, reset, and T underscore in our inputs. So I'm declaring them as reg and wire Q comma Q bar. These are our outputs. Now next is T underscore latch instantiation DUT, enable comma reset comma T underscore in comma Q comma Q bar. These are our inputs and outputs of our design. Now next, I'm going to initialize my inputs. How to initialize my inputs? Initial, begin, enable comma reset comma T underscore in is equal to 0 and followed by end. So I've initialized my inputs. Next, what should I do is I should generate my enable signal. How to generate my enable signal? Always hash 5, or we will take, okay, we will take 10 nanosecond time period. Hash 5 enable is equal to not of enable. Okay. Next, I'm going to apply my inputs within an initial begin block. Initial begin. First, I'm going to apply my reset signal, and after 10 time units, I'm going to deassert it as 0. Next, after 10 time units, I'm going to give my input as 1, and after 10 time units, I'm going to provide my input is equal to 0 and followed by end and end module. So this is my code for T latch. Now let me save this and let me simulate it. Let us see what we are getting. So before that, I need to make sure that it is set to top. And let me run the simulation, run behavioral simulation. Let us check. So this is the output which we are getting. This is my enable signal which we have generated. And whenever your enable is equal to 1, we are applying our reset signal. So your output is becoming 0 and Q bar is equal to 1. And whenever your enable is equal to 1, you have applied your input as 1. So your output is getting toggled from 0 to 1. And Q bar is toggling from 1 to 0. And again, whenever your enable is equal to 1 and your input is equal to 0, your outputs are constant. Q is equal to 1 and Q bar is equal to 0 itself. Okay. So this is how you are going to write down your T latch. Okay. Yes. So any doubts or any queries in T latch? Okay. I hope there is no doubt in T latch. Now let us write down the logic for our JK latch. Create file JK latch. So let's write down the logic for our JK latch. Open this file. First of all, let us declare the inputs and outputs of this latch. Input enable J, K and output reg, Q and Q bar. These are my inputs and outputs of my JK latch. So always at enable, whenever there is any change in your enable, and we will take an asynchronous reset here. Reset enable comma reset comma J and K. Okay. So if enable, so first of all we will write down the reset logic. If reset, then my Q is equal to 0. Q is equal to 0 and Q bar is equal to 1. So I should use begin block. If I am using multiple lines of code, I should definitely use my begin block. So and followed by end. Now if enable, then begin. If my J is equal to 0 and K is equal to 0, then begin. My Q is equal to 1 tick. So my Q will be constant only and Q bar will also be constant. Okay, and followed by end. So this is my hold condition. Next, what is the condition which we are going to have? So output rich Q and Q bar. So what is getting? Sorry, we should write always at the rate begin. Okay, yeah. Next, else if my J is equal to 0 and K is equal to 1, then begin. Q is equal to 0. Q is equal to 1 tick binary 0 and Q bar is equal to 1 tick binary 1. Okay, this is one condition. J is equal to 0 and K is equal to, yeah, and so it is one condition. And one more condition which we are going to write, else if my J is equal to 1 and this is logical AND operation, K is equal to 0, then begin. Q is equal to 1 tick binary 1 and Q bar is equal to 0 and followed by end. And next condition which we are going to have is else if J, or we can simply write else Q begin. Q is equal to not of Q and Q bar is equal to not of Q bar. Okay, and followed by end. That's it. So this is my code for my JK latch. Hold condition, reset condition, set condition, and toggle condition. And followed by end this enable block also, and end this always block. That's it. So this is the logic which I have written for my JK latch. Now let us write down the test bench for this. TB underscore JK underscore latch. TB underscore JK underscore latch, and finish. Let me open this and let me declare my inputs as rich and outputs as wires. So rich enable reset J, K, and outputs are my wire Q comma Q bar. These are my inputs and outputs which I have declared. Now let me instantiate my design JK underscore latch DUT enable reset J, K, Q and Q bar are my inputs and outputs of my design. Now let me initialize it. Initial begin enable comma reset comma J comma K is equal to 0. So I've reset my initialized my all the inputs. Now I should generate my enable signal always hash enable is equal to not of enable. So next I'm going to drive my inputs. So how to drive my inputs? First I will apply the reset condition. Next after some time I'm going to deassert it. Next I'm going to use a for loop here. So how to use a for loop? So how many combinations we are going to have? J 2 combinations and K 2 combinations. So total 4 combinations. For I is equal to 0, I less than 4, I is equal to I plus 1, concatenation of J comma K is equal to I. Okay. So let me declare an integer I. Okay. Now J comma K is equal to I, and let us use a delay here in between hash 1. And if we are using multiple statements, I should use begin and block. Begin followed by end. Yes. So this is the logic which I have written and followed by end. So let us check what we are getting. Let me save this file and let me save the JK latch file also. And let me first of all make it as a top JK latch set as top. And let me run the simulation, run behavioral simulation. Let us wait for the simulation result. Yes, so coming to my simulation, let us check what we are getting. So here my enable, here I'm applying my reset signal, and whenever your enable is equal to 1, your output is becoming 0. So here your output is Q is equal to 0 and Q bar is equal to 1. Now, so from here we are getting our inputs. I is equal to 0, so J is equal to 0, K is equal to 0, hold condition, and I is equal to 1, that is J is equal to 0 but K is equal to 1, that is reset condition. Next J is equal to 1 and K is equal to 0, set condition. That's why your Q is becoming 1 and Q bar is equal to 0. And whenever your J is equal to 1 and K is equal to 1, toggle condition is happening. So you can see, right, it is initially your Q is equal to 1 and it is becoming 0 and 1 and 0 and 1. Okay. So this is how you are going to write down, develop your JK latch, SI latch, T latch and D latch. Okay. So for flip-flops also, there will be the same method, but there will be small difference that we will discuss while we are discussing about flip-flops. Okay. Yes. So that's all about this particular session. If you have any doubts or any queries, you can stay and discuss with me, or else you can leave the session. Okay. Thank you.